Hello to all of you who are interested in learning Python programming language. Okay, after the introductory topics, it is a time for more advanced topics. This time I have chosen Jupyter Lab as the development environment. This environment has many extraordinary features that make you have a more regular and integrated workflow. This environment is used in various advanced machine learning, deep learning, and applied data science projects. This environment is not only limited to the Python programming language, and it can even be used for programming in other languages such as R. This development environment is available among the Anaconda Navigator options, and you can use it. In cases of working interactively, it is better to use Jupyter Lab or Jupyter Notebook. Both of these are web-based. After running front end and a front end that can be seen and a back end whose results whose outputs are transferred to the front end and thus become visible again will be provided to you. This back end is actually the kernel. It performs the calculations and sends the result to the front. This Jupyter is a spin-off the IPython project. And now what is IPython? Stand for Interactive Python. Press the Win and R keys on the keyboard, and after writing CMD, press OK. And OK, press this OK, and Windows command line environment or system shell opens. If you click Python here, you will enter the Python environment. Let's have Python. So Python gives you an interpreter in this way. If we hit exit, for example, we can have some command here. You can see that this is working actually. Hello. Okay, in such case, if we write actually exit, we enter the system shell again. This time we hit IPython and enter another environment, IPython. Okay, this is not operable here because of some software issues here. It should be installed on your system, but this is not such an important thing actually. Here in the if it was installed, you can have an interactive environment which has two lines of codes. One of them dedicated to in lines, and one other one is dedicated to out lines. The in lines is where you can code, you can write your codes, and the out one is the place of showing the outputs. These are not such importance. IPython is an improved environment. It is usually used a lot in educational topics because the command history can be seen in this environment. But as we said, the Jupyter Lab and Jupyter Notebook environments can be accessed through Anaconda Navigator. We close this Anaconda Navigator for we can actually close it if we want to. Let's close this Anaconda Navigator. Okay. Because I previously have installed the Anaconda. Maybe the error is due to this installed software or something about software issues. Actually, these are not such important because the Anaconda's environments and kernels like Jupyter Lab and Jupyter Notebook are very more practical than something like command line and CMDs, and neither us nor any other experts work with such CMDs when a very popular and useful navigators like Anacondas are available. Everyone works with Anacondas, so these are not such important issues. You can close these and join the Anaconda population. Okay. Okay, in the Anaconda Navigator, we can launch the Jupyter Lab. If you launch this Jupyter Lab, the Anaconda will give you a web application. Waiting for the web application, and inside this web application I will provide some explanations for you to become familiar with the Jupyter Lab environment, and then we start the process of learning tips. Inside the Jupyter Lab environment. Okay. Okay, this is the environment of Jupyter Lab. You can have a new file using file, a new notebook. Actually, new launcher. No difference. Through file export. Okay, through file and save and export to notebook as. We can have a file with a different extension from the notebook we have. You can also have this in a PDF format, as you can see here. Actually, in the settings tab, you can go to the theme, and this way you can change the theme. Actually, the important features here are fonts. Finally, the applied changes can be saved, and now I don't want to apply any changes. Each cell in this environment can be a code or markdown here, or raw. We are not talking about markdown features at the moment. We have two different modes on each cell inside Jupyter: command and edit mode. For example, if it is on code mode, can see here, this is now on command mode. Now this is on edit mode. If you click inside the cell, it goes on edit mode. In edit mode, whatever we type through the keyboard is entered in the cell. You can see that here. To run the codes, you can either use the run option or use Shift plus Enter on the keyboard. For example, let's type a print hello. You can use this option or you can use print hello world. Or you can press a Shift and Enter button on the keyboard simultaneously, and you can see it's run. There are three ways to exit edit mode and enter command mode. First one is running the cell code. The second one is clicking somewhere outside the cell. And the third one is pressing the ESC key on the keyboard. There is a series of shortcuts. For example, suppose you want to add a cell before the cell you are working with. If you click the A button on the keyboard, new cell will be added below the current cell. Let's have it. I press the A button. On the command mode, A button, and you can see that a cell is added below the cell which was selected. Now the selected cell is here, which the blue rectangular is beside that, and I want to press B. You can see that an extra cell is added above the cell which was selected. So if you press A on the keyboard, the top of the cell, and if you press B, the bottom of the cell, a new cell will be added to. And now there are many shortcuts. For example, if we are on a cell and press D twice, let's press D twice. You can see that the cell would be deleted. For example, C copies, V pastes in the next cell, and Shift plus V pastes in the previous cell. X cuts. Let's have, for example, let's select this cell. Let's go on command mode and let's press C. Okay, I think that the codes inside the second cell which was selected is copied now. Now I want to paste it. If we press V, you can see that the codes inside this cell, the selected cell, actually was pasted in a cell before this cell. It means that a cell before, above actually the selected cell is at first added, and after the adding process completion, the codes inside the cell is copied and pasted in the added cell. Okay, now let's, for example, select the first cell, go on command mode, let's press C button on keyboard. The code is copied now. Now let's press Shift plus V. Press C and Shift plus V. Okay, this shortcut is not working at the moment. Let's do it on this one. C, Shift V. Okay, this is not working. It's not such important. Sometimes these shortcuts are not working properly actually. But these are the shortcuts. So you can access these shortcuts by using this help. These are very options here actually. You can read something about the Jupyter Lab actually, and everything inside it. These are the Python references. These are the Python libraries actually: NumPy, SciPy, Matplotlib, Pandas, and you can see this is the same IPython which we talked about that. Okay. By default, all cells are on code mode. You can change this mode here. You can go on Markdown mode. Let's try it. For example, let's put a square sign, press a space, and for example print. Let's run it pressing shift and enter simultaneously. This is on code mode, Markdown mode. Okay, a space, run. You can see that it becomes like something like a topic. You can see that here. Our work is with code mode. We talked very briefly about these features. To make a line on the Markdown mode, you can three dash, run it. You can see a line here. Many times it is necessary to restart the kernel. A kernel restart, we can do it by here. Kernel, restart kernel, confirm it, and the kernel is restart. Now if we print, for example, I am Ghazal. Okay, you can see that the number of this code is 1 after running because the kernel was restarted. Typically it should be for example 3 because these are 2. For this you can press 0 twice. This is another shortcut actually. All codes can be written in all environments, but in some cases, for example, Jupyter has a series of features that provided the possibility of interactive coding. My suggestion is to use these more advanced environments. These markdowns are different from comments. Images can be shown in Jupyter, equations can be shown. These capabilities are beyond the rest of the environments. At the beginning of the advanced section, we want to talk about data structures and algorithms. Let's delete all these other cells. Let's have a topic here. So go on Markdown. Put a square sign, consider a space, and have the topic which is data structures and algorithms. Data structures and algorithms. Okay, run the cell and you can see the topic like this. The first thing we want to do is extract variables from a sequence. For example, suppose I have a tuple. For example, A is equal to 5, 12, and for example 35. Let's run it. We have a sequence with up to, for example, n elements, and I want to unpack it. To speak, for example, I want to extract the elements from it. For example, I'll convert it into n variables. How can this be done? You can unpack any iterable sequence into its elements. How? Using a statement. Suppose this A tuple. Now we want to extract the elements. We create 3 variables because the length of tuple A is equal to 3. A1, A2, A3 is equal to A. Okay, let's run the cell. Now let's call A1, run the cell. You can see that this is 5, which is the first element of this tuple A. Let's see what is the A2, run the cell, and you can see this is 12, which is the second element of A tuple. What about A3? And you can see this is 35 too. You can see that these elements are placed in these variables respectively. If the number of these variables is not equal to the number of elements of our sequence, we will receive an error. Let's check it. For example, let's have A1, or let's have another one. For example, a tuple B, 2, 4, 6, and 8. Okay, now B1 and B2 is equal to B. Let's run the cell. You can see that there is an error. How about if the variables and numbers are more than the numbers of elements inside the sequence we have? This time we will get another error too. So the numbers of variables and numbers of elements inside the sequence we are working with should be equal. Okay. These elements do not necessarily have to be whole numbers. For example, consider L as a list. For example, let's consider it Udemy. 33, an integer number. 12.9, a float number. And a tuple, which contains some integers, for example. And 7. Something like this. Run the cell. Now we can see, for example, a square bracket notation. L0 is Udemy. You can see this. let's unpack it. Consider S, I, F, and T as this L. Let's run it now. Let's call them S. You can see this is the first element. I, you can see this is the second element. F, you can see this is the third element, and T, you can see this is the third element. If we want to unpack these tuple 2, we can work like this. We can work, for example, S, I, F, and a tuple which is a T0, T1, and T2. This is equal to the same L. This time you can again call the S. You can see this is Udemy. You can call the I. You can see this is a 33. You can call the F. You can see this is a 12.9. You can call a T0. You can see this is 12. You can call a T1. You can see this is 25, and you can call T2. You can see this is 7. So this is working correctly. This unpacking discussion can be done on all iterable sequences. For example, suppose that we have a string, for example, hello. We can unpack it to S1, S2, S3, S4, and S5. We consider 5 variable because our sequence hello, which is an str, which is a string, has a 5 element inside it. So this is equal to S, and we can now call them S1, S2, S3, S4, S5, and that's it. Sometimes we don't want some of these elements. In these cases, we must act like this. When we don't need an element, we can use a throwaway variable, which is an underscore actually. Let's call the L. What was our L? This was the L. If we want to have just the first and the second element of this sequence, we should act like this. The first one is dedicated to the S variable. Second one and a third one are not necessary, and the last one is wanted again. So these are equal to L around the cell, and you can call them. This is S and this is T. Okay, we will go to the second discussion, which is a continuation of this discussion. Extracting elements from iterable with arbitrary lengths. So let's have the markdown mode. A square sign, a space, and write the topic, which is extracting elements from iterable with arbitrary length. Okay, run the cell and you can see the topic here. For example, you want to extract n variables from an iterable sequence with more than n elements. In those cases, star expression can be used. Suppose you are a class teacher and during the semester you have given several class projects to students and you want to ignore the grades of the first and last project and average the rest. For example, consider this G as our list of grades, and you have, for example, 20 students. The grades are in the 5 scale actually. Let's have a list for it. Okay, let's consider these 20 grades, and you want to ignore the first and the last one. Let's run the cell. Let's consider first as the first variable name. Press star sign and middle, for example, and the last. Assign these to our G list. Let's run the code. Now let's call them. What is the first? This is 2, which is the first element of this G list. What is the last? This is 5, which is the last element of this 5. Actually, this G list contains the grades of 20 projects which you as a class teacher gives to your student. Every student has a G list like this actually. This is the first containing the first grade of each student, and the last containing the last grade of each student. And now let's call what is this code mode? Okay, what is this middle? You can see that this is a list containing all of the G lists elements except the last and the first one actually. Now let's see what is the length of this middle. This is 18, which we expect. So now let's have define a function for the purpose. So for example, let's name it average mid. Okay, and the input argument would be grades. Don't forget to put the column. Press enter, and you can see the indentation is applied by the interpreter. Consider first, star, middle, and last are equal to grades. And then we want to return sum of this middle divided to ln of this middle. Okay, run this cell. Pay attention to the concept that because we do not this first and this last element, so we can use the throwaway parameter, which is underscore for them. You can see this would be not important actually. Let's run it again, and let's call this average mid function with the input argument G, our G list. Let's run the cell, and you can see this is a 3. Actually, this 3 is the average of these middle grades. Okay, here the first lecture of our Python programming language tutorial advanced level is over, and I highly recommend you actually stay tuned because very useful and practical tips are awaiting for you in the upcoming lecture. This one just dedicated to becoming familiar. Stay tuned. Have a nice day.